Let's talk about the topology. So we talked about we gave you various characteristics to differentiate between the computer system. One is what we call them the distance. Second is called the topology. How they are basically, how the signal is being carried over. The bus concept itself, you might be aware of the computer hardware design, but here bus is basically again is a complete logic for transferring of the data from one machine to another machine and so on. So when we say on the bus network, this is basically, I have shown you that we have various networks, various machines, and there is a common wire going all along. This is a type of configuration which you see in the computer network. You have a number of machines, but they all have a common physical wire, and the signal will be transferred both ways. So if I have to transfer from 4 to 5, again these might be go this side and that side, but the informations will be captured by 5, because the address of 5 will match only with the address of this machine. So what we are talking about, the bus type of topology, the signal will move in both the directions, information will be in both the directions, but it will be captured by only that machine whose address is basically put into it. And one thing we try to understand with the day-to-day activities, when I send email, when I do the surfing, the informations are transferred into certain packets, and this is the basic unit of transferring the data, although as a programmer, I usually don't visualize them. So when I send email, my email will be put into certain format, let's call it frame, or let's call it packet, and that packet will contain not only the content of the information which you are sending them, but also where from the information is coming, certain address of the your local machine, address of the remote machine, and then error correcting information also. Error correcting is, for example, you must have learned in computer network the ASCII system. Now for example, we say that let's say the capital A. Now capital A is again represented by 8 bits now. So the 7 bit is basically meant for character representation, but 1 bit is meant for the what we call error correcting codes. So it's called parity bit, even parity, or the odd parity. So the same concept is used here also when you send your data. So when you are sending email, along with your information, also error correcting mechanism is going along with it. So this is what we are talking about. Information can go in both the direction, but it goes in certain format, what we call them packet. And same topology we use them in the local area network. And then we have the star topology. Now in star topology is this is basically the central system, here what we call them hub. Now here all the machines are not directly connected. The information from one machine to another machine will always go through this hub. So it will be routed through this. Now what is happening here is that if one is down, then everything will be down. If your hub is not working, or the central system is not working, then all the informations will be blocked there itself. It is the simplest technology. We have used it earlier. So the simplest technology, but still what happening is the drawback with this type of technology is once this is down, then information will be not be carried through from any machine to any other machine. So now, okay, now so again the same information that this allows all stations to see each packet on the network, but only the station the packet is addressed to the address and pays attention to it. Now again we have ring technology. So two most popular topology in the computer network is the what we call them bus topology, and IEEE 802.3, which I gave you earlier, is basically used for this protocol for this type of topology. Then we have a ring topology. All these machines are put into certain ring structure now. So if one machine will send, but to send the data into a ring type of a topology, you must have the control with it. Right? Anytime in bus topology, anybody can send at any time. But in ring topology, any sender must have a control, and if you have grabbed the control, then only informations will be sent to the another person. So information will be circulated around the ring in one direction. They can move in other directions also, and depending upon which address it matches, the informations will be grabbed there. So this is another topology. So now we have another protocol for it. So now again we have I told you that today we are moving with a different type of computing paradigm, and what we call them is basically mobile computing paradigm. So the topology is again it should not be physical, should not be wired type of topology. We call them wireless topology, and this is going to be a standard for after some time, that this is people will be use this one as the most useful computing topology. Now here they are not physically connected. Wireless topology components generally include a PC, right? And how is it different from the topologies which we covered into ring and others? They contains a PC, a transmitter and receiver, and a software program loaded into the PC. So must have some transmitter and receiver, and basically the signal is carried through that media. And here is again, but again compared to all those technology which we discussed, it is little bit slow, and lots of other problems are there. Even TCP/IP have started supporting the wireless type of thing. When we say the TCP/IP protocol, the basic understanding is that they talked about only the physical media, coaxial cable and this one. But now the TCP/IP, what we call them, the next generation of the TCP/IP will also support this type of, that one can send email without being connected through some physical wire. While moving, one can send. So TCP/IP protocols also. So still we have lots of technology, still not very matured. It is very slow and also the error prone type of thing. So still not, people are not using them, but protocols have been designed to support this type of technology. Again, the drawback is limited in distance, and it has to be again most of the time the system information is not very reliable. Now this is the Ethernet. This is the one standard today we use in the computer network, what we call them local area network. Ethernet is an open network connection developed by the Intel Digital Equipment and the Xerox. So this is the standard most of the people have adopted in the computer local area network. And the topology, again, they use the what we call them bus topology. So this is the basic topology we use for the transfer of informations in a local area network. Now, but it offers variety of protocols. But the protocol which you have to understand that the basic protocol is 802.3, or what we say that IEEE 802.3. But just we have shown you, just this diagram will show you that how the token ring network is working. Just diagrammatically we are trying to explain to you that the three machines are there, and right here it might be the server, the other two client machine. And just see this, just follow the red. This is basically showing you how the control is moving here. In the ring topology and token ring network, there is a and this red one which you see here is a basically control now. You must grab this token if you want to send the informations there. So, but in bus topology we don't have this type of situations. Anybody, anytime they can send the data. They have to simply sense the channel, whether the channel is free or not, but they should not have any type of control or token. But here in token ring network is what we call them. It is that you must grab the token, and then you can send the data. And also the major difference between the two is we say that token ring protocol is what we call them deterministic protocol. And so deterministic means that you can use this type of protocol in real time applications. For example, if I am working with the nuclear installations type of environment or the chemical type of environment, the some operation has to be done very fast or within a stipulated time that you can't do with the IEEE 802.3 or what we call them bus topology type of system, but you can do with the token ring network. So two most popular topology which you have is what we call them token ring and then token bus. Again, here is same thing what I have already explained to you, that the access mechanism is token is a little bit different from what we have already covered. See this one in the bus, that you must have a permissions, and that permission is granted through this token which is circulating all around now. But of course there will be a problem. If a token is lost, then a whole network has to be reinstalled, because without token the protocol will not work at all. So you have certain complexity here compared to the bus topology, but it's much more deterministic type of thing, and it has got very wide applications in the strategic area of applications, let's say defense or the chemical type of Okay, now, so here is the again sometimes you can see that they can it can be, of course it is not here, that the token can be moved into various directions. It can go actually moves into the one direction, but there could be more than one token also. They can move in both the directions also. Now basically this point is already explained to you that we always work in the client server environment. Client server environment is that here is the in client server environment everything is stored. The most of the server we have a one machine what we call them server type of machine, another machine is what we call them client type of machine, and all the serious applications are being stored into the server machine, and the another program through which you access the server is stored on the client machine. Now this is other applications. This is the architecture of the client, and most of the time you are going to develop the software into client server applications now. So basically sometimes we say the two-tier architecture, client part and the server part. For example, they sometimes say that you are designing something into the Visual Basic, like something like this. Most of the students are doing a project like this, that they are using Visual Basic and Microsoft Access. In that case, the Visual Basics becomes the what we call the front end, and the Microsoft Access becomes the back end. So the back end software might be stored on the server, and the client software or front end application software is stored on the client side. So most of the time you are working at your applications into this type of architecture, and this has become the standard in the industry for development of this software applications now. And here we have shown you that how the client server people are working. Okay, there might be one server machine is there, something we say that this is machine, where all the important applications is stored there, and all people are trying to access the resources. Now we have we'll talk about another applications. So let me give you some other advantage of the client server type of environment, that the centralized security. You don't need to distribute the security all around the machines. You have to put everything on the central machine. There could be a dedicated machine, what we call them server, so you have to look after only that machines. Easy accessibility, because we are talking about two-tier architecture. Client is talking to server directly, not through another type of clients, and so on. Another the facility, another support which you have, which system administrator is aware of, is that easy backup and the synchronized type of files. The word synchronized has to be very much understood. By synchronized means that if one file is being updated, if another request is coming from another client, they all have to be in the queue. Same example you can see in the railway reservation, that if somebody's ticket is being booked, if some other request is coming, then they all have to be in the queue, because the files, all the information, all the file updations and retrieval has to be in very much synchronized manner. And again you have a since you are working in the client server environment, again you are dependent upon certain administrator which is looking after the server, and the server is again very costly type of setup compared to a standalone type of system. Now again we have the peer-to-peer network architecture. Here basically just I will give you some brief idea. Here we are talking about something called three-tier architecture we are talking about. Again means that there is a server, there is a basically applications client, but we have another business logic that is dedicated to particular type of organizations. Means the server is quite generic type, client is quite generic type, but if you want to have something dedicated to certain type of organization like security issues and what we call them some other proprietary issues which you want to implement, that we put at the another layer. So we have when we say peer-to-peer, basically means we are talking about three type of architecture. There is server, there is a client, and in between we have another type of layer what we call the middleware architecture, and that is basically proprietary type of applications. They do all the business logics, all the security issues, they put it at this layer. The same thing already we have explained to you. Again we have a disadvantage of the network, again compared to the because the server is little bit now less overloaded compared to the client server type of architecture. In client server The server contains most of the information as well as security issues as well as the proprietary issues, whereas here we have reduced certain things, certain overload on the server, so it becomes, the setup it becomes much easier, it becomes inexpensive, the maintenance becomes much easier because the information is distributed at another layer. And again we have some disadvantage, some other all these security issues. Let's go to the physical media. The medium is there. We have already discussed, we have a wired medium, we have a wireless media. So the coaxial cable, fiber optics, twisted pair, they all come to the what we call the wired media. But today we are talking about the wireless media also because of the mobile computing applications. So the another important emerging paradigm in the computer network will be the wireless media. And most of the protocols today, the TCP/IP also coming to support the wireless media. Means with the TCP means while moving you can work with the, if while moving you can surf your data from the internet, you can send some data into the through internet, you can do chatting, you can do the emailing, everything will be in mobile, and that is what we call them, that will be supported through the wireless media. And then when we have this is what we already explained to you, what is the bonded media. Basically we talked about all the physical media which we listed earlier, they all belong to the what we call them bonded media. And then we have various examples: optical fiber, twisted pair, coaxial, and then unbounded becomes the wireless media. Here is basically where the but again told you there is a drawback with the wireless media. The technology is still not very mature. The distance, again the noise problem is still not being sorted out. So the reliable informations cannot be sent through the wireless media. So the three types of wireless media are there. Again the frequency range will be different here, the radio wave, microwave and infrared. So all this technology is currently being used for the mobile computing applications. And here is some we have given you certain examples of the what is the coaxial cable, the media. Basically I will not go into very much detail of all these things because it will be coming in your next session. So here is some here is that coaxial cable is very much widely used in the local area network, but is also used in your cable TV where the cable is basically coaxial cable is used for sending the television signal. And I told you that the bandwidth, to understand the media, the most important characteristic is to know that what is the basically bandwidth. And I told you that 500 megahertz bandwidth is basically this is the supported by coaxial cable type of media. Again, the data transmission compared to the twisted pair is very high quality. The maximum data rate which has been achieved by 100 megabits per second, and told that if you have a more bandwidth, more data rate can be supported. But with the same bandwidth also you can support more data rates by doing different encoding techniques. But again there is some problems, the signal loss at high frequency. And then we have again twisted pair, which is basically used for the carrying your telephone signals from your home to the switching exchange and so on. Again this is also being used in the computer, the local area network, but the data rate is very small. So if you are thinking in terms of the megabits of the data transmission, then definitely the cable you have to use the media. So when we say the high fast data rate, is not only in terms of the protocol but also in terms of you must have that type of media also supported at your side. Now again we are talking about the optical fiber. This is the most the highest bandwidth rate is from this side. We use this one high, and quality wise also the security also very also fully supported with the optical fiber media. The frequency range comes into this megahertz. And the single fiber can also support around 30,000 telephone lines. So just you see we use most of the time we are using this type of technology today in the local area network, wide area network also. And these are the various some characteristics we have given you: the data transmission rate of 400 MBs per second. Now, how to come from bandwidth to data rate? But again, there is the two laws in the computer network, what we call the Nyquist law and the Simon's law. So the whole how to calculate the data rate from the given existing bandwidth, like for example, I showed you in the previous slide we talked about the bandwidth of this one. Then here we are talking about 400 Mbps. How we came to this calculation, that is based on certain formula, and that formula is basically supported by two laws, what we call the Nyquist law and Shannon law. And the difference between these two laws is that one, suppose the ideal type of environment, there will be no noise, signal will be carried over as it is, and the another one talks about the noisy channel, where most of the time signal is not delivered as it should be delivered, and accordingly the data rate is calculated. So here we have given you some ideas about the different type of physical media. And again in this slide we are talking about different wireless media. We told you the infrared, the another type of radio wave, and here we have given various frequency range for all these wireless media. Okay, so now again here again certain characteristics has been given. Now the most important component in the computer network will be the router, what we call them bridge. We have a server, modem we use. So all these are the basic components from the computer network. So if you want to understand the computer network, you have to understand all these devices, and all these devices are used at different layers. I told you in the beginning that in computer network we have the way we design operating system, same way we design the computer network. We design in terms of layers. So lower layers we have what we call them physical layers, and at the higher layer what we call them applications layer. So all these devices are basically sitting, some of devices are sitting at the physical layer, some devices are sitting at the network layer, some devices are sitting at the data link layer, and so on. So as we go ahead, as we talk about OSI and the TCP/IP model in the next session, then we'll talk about all the devices in quite detail. So they all are basically used for carrying the signal. For example, in this case, take example of this bridge. Now bridge is basically used when we want to transfer data from one local area to the another local area network. Again the router is basically used when we want to send the signal from one network to another network. So when we say the bridge, basically we are talking about from one LAN to another LAN, and all the LANs are basically defined at the data link layer. So you have to know various protocols and to understand how the data link layer works, how the physical layer works, then only the role of these devices will be little bit clear. And so we have given them what is the repeater, what is the bridge. Here a repeater is basically simply carry the signal. So basically they do some amplifications of the signals, and then basically this is basically more sophisticated type of repeater with logic capability that filters the packet. Sometimes they will not allow a packet to be flown into the next this one, so they will able to. So we have basically given you the purpose of this whole presentations was to make it clear that what is a computer network, how the new computing paradigm is designed around the computer networks, how we differentiate from one computer network to another computer network, and we listed you that topology is one factor, then we what call them distance is another factor, then protocol is another factor. But to understand the computer network, you have to understand various other components, what we call them repeaters, bridges, and so on. And with this, I want to conclude my sessions. Thank you very much.